Hello, geometry. Welcome to 5.4, equilateral and isosceles triangles. This one that I usually enjoy. Equilateral, of course, is going to be equal lengths, equal sides. That's equilateral. Isosceles is going to be two equal sides. Okay, so equilateral has three equal sides. Isosceles is at least two equal sides. So as mentioned a couple lessons ago, equilateral triangles, oh, there you go, now you can see it, three equal sides. Equilateral triangles are isosceles triangles, but isosceles triangles aren't necessarily equilateral triangles. Okay, so we're just going to jump in here. Okay, some vocabulary here. We have legs, vertex angle, base, and base angles. All of these deal with an isosceles triangle. So I'm going to draw a big one over here. I'm going to say that one equals that one. And those two things, those are referred to as the legs. We're going to say the two congruent sides of an isosceles triangle. The legs are the two congruent sides of an isosceles triangle. So we got a leg, and we got a leg. Okay, two legs, stand on two legs. Vertex angle, that is the angle formed by the two legs. The angle formed by the two legs. So here's the leg on the left, here's the leg on the right. That makes this angle right there the vertex angle. Okay, that's the vertex angle. The base, that is the third side. This is my base down here, so the two legs stand on the base. Remember it that way, two legs standing on the base, third side. The base angles, notice it's plural. So these are the angles formed by the base and either leg. We'll see this later, but they will equal each other. They will equal each other. So these are the base angles right in here. Base angles right there and right there. And I'm going to put little arcs in there because they're going to be the same measurement. Okay, so there's your breakdown of an isosceles triangle. Aren't we excited now? So the base angle theorem. Again, if I'm going too fast, just pause it, catch up, then replay it once you're ready. If two sides of a triangle are congruent, that means you have an isosceles triangle, two sides, then the angles opposite them are congruent. Okay, so that makes the base angles equal to each other. So a good question for that is, let's say we have these two sides equal. Let's say that's 8 inches and 8 inches. And let's say this is 40 degrees up here. There we go. Now we can see it. So we have two sides that are equal. That means the two base angles, this one has to be equal to this one. So let's say we want to find that one over there. Well, if that's x degrees, that means this one has to be x degrees. So x plus 40 equals 180 degrees because we have a triangle. So 2x, x plus x is 2x, minus the 40 over, 180 minus 40 is 140. So x is going to equal 70 degrees. So those would be 70 degrees down there. Okay, that's what the base angle theorem is going to say. Now the converse of the base angle, so here's your base angle theorem. Remember, the converse is going to take the conclusion and then write the hypothesis. So if two angles of a triangle are congruent, then the two sides of the triangle opposite those angles are also congruent. And the sides opposite them are congruent. So the converse is true. So if the converse and the original theorem is true, then you could write a biconditional statement if you wanted to. Two sides of a triangle are congruent if and only if the angles opposite them are congruent. So this goes the other way if you're given two angles. So let's say this is 55 degrees and this is 55 degrees. This is 120 feet, and they want to know what that is. Well, these two are congruent. That means this side and this side, those are the ones opposite, have to be congruent, so x equals 120 feet. Okay, so those are your isosceles triangle theorems. I think it goes into your equilateral theorems, which we've already talked about a little bit with this. If a triangle is equilateral, then it is equiangular. 3 60-degree angles. Equal angles. That makes this 60 degrees, this 60 degrees, this 60 degrees. So it doesn't matter the size of the equilateral triangle, it's always going to be 60 degrees. Okay? If a triangle is equiangular, then it is equilateral. So we'll say the angles of any equilateral triangle are always 60 degrees. And if you have 3 60-degree angles, then you know it's equilateral. That's what the second one's saying. If you have 3 60-degree angles, then it's equilateral. Okay, a lot of diagrams coming your way. So complete the statement, state which theorem you used. So if NJ is congruent to NM, so let's see, I'm on black right now. So if NJ is right there, is congruent to NN, then angle what is congruent to angle what? So here are my two congruent sides. Notice the triangle. So the opposite side would be over here. That'd be angle M. Now I can use just the letter M because it's the only point right there, only angle with that point. And opposite this side would go over here. That'd be angle J. Okay, that was an isosceles triangle theorem. They gave me the sides, and I stated the angles are congruent. So that's the base angles theorem. I started with the sides. See how they started with the sides? And then rewrote the angles. The angles followed it then. So I'm going to say base angles theorem. Okay, this one looks to be starting off the same way, so we might have the same sort of situation. If LM, I'm going to switch to red. So if LM, here's LM, is congruent to LN. LM, here it is right there. Sorry, pointed at the wrong one. Is congruent to LN. So here are the two legs. That makes that a leg. That makes that a leg. So opposite them, here's your base, and it's going to be the two angles formed on either side of the base. Two angles formed on either side of the base. That's this angle, which we can say is just M. Now I can't just say N because it could be any one of these angles, so I'll have to say L, N, M. L, N, N. M. And that's again the base angles theorem. Okay, notice now they're giving us angles. That's probably going to tell me they're saying we're going to use the converse of the base angles theorem. Because if the angles, then the sides. So let's see here. NKM, NKM, so this angle here is congruent to NMK, NMK, this angle here. So the sides opposite those would be, from this first one, go opposite. That makes this the base up here. These are the legs. So the legs are congruent. So MN would be congruent to NK. And we're using the converse for the base angles. Okay, this next one's going to be the converse as well, because we're starting with the angles. So LJN, LJN, there's that angle, LJN, and LNJ, LNJ, so that angle there. So that makes this the base. The base connects to the two base angles. The base connects to two base angles. That makes these the legs. So it'd be LJ and LN. Okay, the base connects the two base angles. The other two sides form the vertex angle, and they are the legs. Okay, find the value of x. Okay, this one, you see these three? That means it's equiangular. Angular. If it's equiangular, it means it's also equilateral. So x has to equal 31. Just that simple. X has to equal 31. This one, we have the three sides. That means it's equilateral. And that means our angles have to equal 60 degrees. So the angles have to equal 60. So 2x has to equal 60. X would equal 30. Okay, so those are things you got to recognize. You got to know this well enough to say, hey, all these should be the same because the angles are the same. All these angles should be 60 because the sides are the same. Okay, getting into a little bit more, you can definitely make these very expansive and get lots of diagrams going on in here. You're looking for isosceles and equilateral triangles. So find the values of x and y. I see two congruent base angles, so this makes this an isosceles triangle. I see three congruent sides, so that makes this an equilateral triangle. Okay, so if this is y degrees right here, these two have to be the same. This is x. So x has to be the same as this side, because they're isosceles, and this side right here is going to be the same as this side because it's equilateral. So we know x has to equal y minus 25, okay? And I'm not sure if that helps us out much. Let's see if we can find y. So what do we know? We don't know any angle measurements. We know this is 90, so I shouldn't have said that. We do know. That's 90 right there. This is equilateral, which means this is 60 degrees. 60 degrees, 60 degrees, equilateral, all 60. So if this one is 90 and this part is 60, that makes this part 90 minus 60, that's going to be 30 degrees there. So if this is since this is an isosceles triangle, our base angles, okay, should be the same. So if you're looking for the base angles, you want to take 180 minus the vertex and then divide by 2. You're going to get 75. Okay? So when you're when you're looking for the base angles, you know the vertex. 180 minus the vertex angle divided by 2. That's how you find a base angle. 180 minus vertex divided by 2. So we get from that y is going to equal 75. Take that y, let's plug it in there. So x would be 75 minus 25, which is 50. So x equals 50. So you see all the steps you got to do, and you got to kind of figure out what is important to find out first. You can't just jump in and find any variable you want. We did set an equation, but we found out, okay, we need more information, and we went from there and we kind of tried to figure it out. So you have to show some persistence, a little bit of stubbornness with this, and don't give up. Okay, keep working at it, don't give up with it. Okay, again, isosceles triangle. We have a vertex angle of 40, so let's find these base angles here and let's get our x value. So if we want the base angle, we have to take 180 minus the vertex divided by 2. That's 140 divided by 2, so that's going to be 70 degrees. So this is 70 degrees. That's x. These have to be the same, so I know 2y plus 10 has to equal x minus y. We do know a number for x. Remember, x equals 70, so we can plug that in. 2y plus 10 equals 70 minus y. So let's solve for y. Get the y over. Go ahead and minus the 10. I get 3y. 2y plus 1y, that cancels. 70 minus 10 is 60. Divide by 3, you get y equals 20. So x is 70, y is 20. Okay? Just remember to find a place to start. Okay? Jump in and see what you know, see what it's giving you, and figure it out from there. Okay, a lot of different variety of questions with that. Feel free to ask what comes up, anything that's different that you don't quite recognize. If you have a question with it, feel free to ask. So we'll see you in class. Good work.